Hey everybody, welcome back to HPC Tech Shorts. My name's Brendan Buffler, speaking to you today from London. Tech Shorts is all about taking you into the water cooler on a weekly basis. We take you into the HPC engineering water cooler here in AWS, and we talk to some of the engineers, the architects, and all of the other folks involved in building AWS. And we talk about different topics related to HPC that we think are interesting from week to week. This week, happy to say, I'm joined by my colleagues Rex in Seattle and Angel, who's in Philly. Hey guys.
Howdy.
Rex is one of our software engineers that works on the ParallelCluster team. So if anybody's been using ParallelCluster, you're using some of the work that Rex has done. And Angel is kind of ubiquitous and fairly well known in the HPC community. He's our principal developer advocate, and he's based out of Philly. So how you going, guys?
Doing well.
Angela, you've got a snake and a turtle, and Rex is a cat, and I've got a dog, and I kind of think that we need to make sure that none of our pets.
This is like rocks, paper, scissors, except animal kingdom.
Animal kingdom. I need to keep your snake away from my dog and my dog away from Rex's cat, and Rex's cat away from your turtle. Okay. Right.
Yeah, exactly.
It's indefensible. All right. Yeah. So today, the topic we're focusing on today is heterogeneous instance types in ParallelCluster. If you're an AWS ParallelCluster user, then you've been using for some time. You've been building canonical Beowulf clusters in AWS, and it's cool that they're elastic. One of the things that customers have been asking us for is for the ability to have those, have different queues inside the cluster of different compute types, and have different queues associated with different kinds of workloads, or at least optimized for different kinds of workloads. Being able to tweak it a little more. And so I'm happy to say that we launched all of that functionality in ParallelCluster version 2.9, I think it was, 2.9.0, back in November. And we haven't done a good job of talking about it to everybody up until now. So today's our day for really getting into the details there. Angel, do you want to, I think it's best if we back up a minute and maybe explain why this is useful, because I think it's worth zeroing in on a couple of example use cases of why this is useful and the sort of things, the customer use cases that we invented this for. So can you drill into that?
Yeah, absolutely. If you could bring up the little whiteboard. So if you see here, like we've said, there are a lot of different types of workloads that go into HPC, whether that's, weather modeling or high throughput genomics or machine learning. HPC is a critical component of a lot of different types of research, scientific workflows and production workflows for our customers. And what the cloud really has to benefit for different customers, different workloads, is the fact that you can get different instance types, right? The traditional model of HPC is essentially a procurement of a homogeneous resource, so that you can efficiently schedule the jobs across that homogeneous resource. But oftentimes that results in a not a great fit for the any given workload that might, for instance, need more CPU than memory. So the different jobs have different needs, right? Sometimes you just need more CPU, more threads to be able to crunch through the processes, or sometimes you just might need like a big honking box of memory in order to bring a very large hash map into memory so that you can do efficient sorting of the algorithms. So
you're speaking from bitter experience there.
Yeah, and I did, and that's actually one of those things that brought me to cloud, was the need for a big honking box of memory. And I was running local HPC infrastructure at that time, and it was either spend $50,000 to upgrade our entire cluster, Or do an experiment on AWS back in 2008 when they first released the big honking memory box, and it turned out that that was a good idea because it did cost us, about 10 times less to do an experiment that ultimately was a failure. It was a bad idea, but it let us ask the question, right, in the first place. So that's great. Like, we actually got an answer. So if you see the diagram on the right, it's just a really high level depiction of what we're trying to do. With our workflows, whether it's weather genomics or machine learning, we want those jobs and processes to be able to dictate, hey, I am a sort of very compute intensive job. So if you look at where we're going with this purple arrow, we really want to use our compute optimized instances, or if you've got the memory intensive job like a genomics or RNA mapping, which might take quite a large amount of memory. You want memory intense R5 instances, for example, and machine learning as well. Whether that's inference or whether you're doing training, you might want different sorts of resources, even within a single workflow, a single set of orchestrated applications that work together. And so we're discussing compute needs, right, at the individual level. We also have a need to look at really different levels of service for any given application, right? If something's mission critical or somebody's life depends on it, you really want a guarantee that job is going to finish at some well understood boundary of time, right?
And you should not be using Spot. For sure.
Well, yeah, it's actually yes and no, right? So we do find that Spot's fairly reliable, and we have some industries which have very tight turnaround times and are cost conscious. For instance, ad delivery, bidding on ad jobs. That's a very low margin business that needs pretty good guarantees that they're going to get an answer, or they lose the opportunity to service that customer. They predominantly do use Spot. But nobody's life is on the line if you can't sell that ad, right? Yeah. So it's more about a business requirement than it is a capability and the risk profile for that business requirement, right? So we actually think that the Spot market works well for a lot of things that you may or may not want to. But given a business requirement, you might choose to use on-demand queues and on-demand instances because it just, you're meeting a business initiative, not and even reserved instances. In fact, you're going towards what the actual workload needs from the return of results guarantees, right? Whereas something like, if you're doing satellite image processing to create different tilings, that's a non-priority job. You'll eventually serve those out. You can confidently go to the Spot queue and Spot instances for that sort of workload.
So you could totally have a queue that's being, where the instances behind the queue are being supplied by Spot. You could have another queue where they're being supplied by on-demand. Mm-hmm. And those instances could all be actually they could be different CPU architectures, like what your diagram top says, different CPU architectures. They could have GPUs. There could be any number of things, right?
Yeah, that's correct.
In one partition in one queue.
I'll punt that question to Rex.
Yeah, that's probably a good idea. Rex, can you have multiple different instance types in a single queue?
Yes, absolutely. So with ParallelCluster today, the latest version, which is 2.10.2, you can have up to 3 instance types in a queue. And you can have a maximum of 5 different queues. So that should give you some options in how to configure your queues.
Okay, it's worth saying. I think we have to point out this is very Slurm specific. This heterogeneous instance types, because it's using an aspect of Slurm that we've leveraged, right?
Yeah. So this heterogeneous instance type architecture is really made based on the Slurm cloud bursting or power saving plugin, and it really ties. It's really like scheduler based, so it works well with the scheduler. And this is where I think I should drop a plug. So even if you're a user today that only uses, say, like a single queue and a single instance type, you should also do the upgrade and use the new architecture, because it's just integrate it better with the scheduler, and it's going to be more stable during scaling activities. So yeah.
Well, there's also, and you and I, the three of us were talking about this morning. This is particularly cool. If you're an existing parallel cluster user and you've been using it for some time, you would know that when the scale up operation happened, because there were jobs in the queue, you know, pending some resources, we'd scale it up a few cores at a time or an instance at a time. It actually does. It's actually job level scaling now, right? So, do you want to describe that a bit better than what I'm doing?
Yeah, sure. So I can just give like a high level description of how the scaling works. So basically, as I said before, it's all scheduler based. So when you submit a job to the Slurm scheduler, the scheduler is going to assign the job to any available nodes that are already online. And because those nodes can run the job right away, right? So in that case, no scaling is required. But you know, if all of your nodes are occupied or you don't have any like online nodes, then the scheduler is going to assign the job to nodes that are in power saving state. And once it does that, it kicks off this whole power saving loop or cloud bursting loop. So like our resume program is going to launch the instance for those power save nodes to bring those nodes up. And you know, once those nodes are up, they're ready to run your jobs that are already assigned to them. So cool. Yeah, the whole process is very, you know, job driven. So we don't scale up by a fixed amount or anything like that. It all depends on the state of the job queue and how Slurm, you know, assigns the jobs to different nodes.
Yep. That's cool, and that, I mean, that's a big deal. I guess we, you know, in the interest of time, we better let's get you to show us some of this stuff in action. Do you want to share your screen and I'll?
Yeah. Yeah, absolutely. So let me share my screen. And one moment. So we can probably cut this part out. Can you see my screen?
There it is now. Yep. Excellent.
Perfect. Yeah. So yeah, today I'm just gonna show a quick demo of basically using the parallel cluster update functionality to update like a queue of an existing cluster that we have. And you know, this is going to give us like a idea of how a heterogeneous instance type cluster is going to look, and also it shows off our P cluster update functionality that allows you to change the configuration of your queues basically at any time. And it's a great feature to use, you know, if you want to adjust the setup of your cluster. So first, let's take a look at our base cluster, which I've already created. So we can do a P cluster this. Let's do a bit of color. Yeah. So as you can see, I've already created a pre-baked cluster, our demo cluster that we'll be working with today. So we can do a P cluster SSH into that demo cluster, and we can see that cluster right away. And oops.
Wow. Parallax. I just saw that. Recursion.
Oh no. All right. But in the meantime, I'm gonna pull up our the config I used to create this demo or this cluster. So there it is. All right. And yeah, so you know, since we're using the Slurm cluster, you know, we need to do sinfo to check out our Slurm partition or Slurm queues. So as we can see in the right, this is a really basic cluster configuration file, really with like the bare minimum of parameters, configuration parameters. So, you know, we have very basic things, our VPC setup, our key, our base OS, scheduler, our head node instance type, and, you know, our compute instance type. And today, you know, for this cluster, we're using just basic C5.xlarge for our compute. And as you can see here in our cluster, we have some C5xlarge compute nodes sitting in the cluster. And yeah, so this is, you know, so this just shows, you know, basically a single instance type cluster, right? Which is probably what most users are used to before.
By the way, it always weirds people out when I show them that we can take a config file like this, type a command, and have a cluster getting built in a few minutes. that there's always a big smile on people's faces when they realize what's going on.
Oh yeah, yeah. Thank you.
Yep.
Well, wait till the
everything from
update.
setting up the VPC defaults and everything else. It's not just the compute itself, but everything around it. It's very, very nice piece of kit that we have here.
Yeah, thank you. Okay, so with that, we are actually going to run our update. So we're going to log back out of this cluster, and we're going to take a look at the configuration that we're going to use for the update first. So let's do a sconfig demo update. Okay, so as you can see, this is a slightly longer, configuration file. And what's changed? So we can compare these two configurations side by side. So as you can see, this is a configuration file for multiple instance types and multiple queues. So instead of just specifying a compute instance type, we have some queue settings. So I've specified 3 queues. We have our on-demand queue, which has some c5.xlarge instances, and also some on-demand g4dn.xlarge instances, just to demonstrate that you can have multiple instance type within the same queue.
Yeah.
And we have our spot queue, where we just have a lot of c5.xlarge spot instances. And at last, we have a GPU queue, which I've put some like larger g4dn.12x large instances in that queue. It's just a personal habit. I like to put the larger instances, maybe in a queue by themselves, so I don't submit the jobs to those instances like accidentally. So this will be the configuration we'll use. Yeah. And now we're going to run the update. So again, we can do a pcluster list to show our cluster. So we have a demo cluster right here. And we can do a pcluster update. Oops, update. Do demo, and then we'll specify our configuration that we're using, which is config demo update.
Dramatic pause.
And,
it's the enter key.
Right.
This is saving somebody like a year and a half work running an RFP, buying the nodes, having them installed, going through the test plan, the acceptance testing, having a dozen systems integrators in the building for a month, building stuff. This is
Yeah, that's correct. Like if you had, a new group coming to use your shared resource that now wants to use larger instance GPUs, for instance, a new family of GPUs like the P3s or the NVIDIA V100s or A100s and the P4s, you could just add them into a specific compute resource under these queues, and you'd be ready to go. I've got a question for you though, Rex. What if I'm a parallel cluster user and I've been using version 2.7? What's the update process to get to the version 2.10? I saw both of them were 2.10. What about previous versions of parallel cluster of things that I might already have stood up?
Yeah. So as you can see, like the configuration between the say the multiple instance type cluster and the traditional single instance type cluster is a little different. So we actually have a utility that can help you maybe to ease that transition and help the user start to use a new format. So I'm actually going to show that right now as well. So as you can see, we have the clustering update already, so we can actually leave that process and let it run for a bit. And then I can show off the pcluster configure utility. And so this utility comes with the parallel cluster CLI. So if you have AWS ParallelCluster installed, you should already have this utility that you can use. And what this does is we can take a configuration of an old format. So we can do a convert, and we can take our old configuration file, config demo, and then we can output that to, let's call it converted config, right? Okay, so it's gonna do something here. And now let's take a look at our converted config. Yep. Cool. And on the left, I'm gonna pull up the old configuration file as well. so we can compare the two side by side. Yeah, so as you can see, the utility just takes this configuration file that's that supports the single instance type and turns it into a format that it's easier to work with and to specify multiple instance type. So it just does these automatic conversions of, say, like converting the compute instance type into into queue settings and into your like compute resources. So this is a pretty handy utility that users can try, and this might help them to transfer from an older version of ParallelCluster into the new version that supports the multiple instance types. Yeah,
that's sweet.
Great.
So hey, show us the new cluster now. That's
So let's see. Oh, it says updating progress. So that's gonna take a little bit of time, but should be done within 5 minutes or so.
Yeah, but we have the Julia Child's second oven with the demo backup. So let's take a look at the keys. Let's go take a look at the keys earlier. In the second.
Yeah. Of course, we can pull the second cluster out. So since that one's already that's still updating, we can check out the one I've already made and updated. So we'll do a pcluster SSH again, and then we can log into our backup cluster. Yeah. Great. So now we're in here. So these clusters are identical, created and updated with the same configuration files. So again, we'll do sinfo to show the queues. And yeah, as you can see, again, I'll pull up I'll pull up our update configuration file just for everyone to see. So yeah, as you can see, it's exactly as we've configured. We have 3 queues with the instance types that we've specified, some C5x large, some G4DN.x large, and then of course some G4DN.12x large. So that just shows, you can easily update and reconfigure your cluster with the pcluster update functionality.
That is really cool. That is really neat. So now we've got so to recap, there was basically just a few steps there. If a customer started with a single instance type cluster in the old way of doing things prior to 2.9, they use a script to upgrade their config file, give birth to a new cluster again, and then they can just follow the steps that you did, which is updating the config file, adding a few more queues or a few more partitions, different instance types, and then doing a cluster update, which then just updates it to, with these multiple queues and so forth. And it's ready to rock in, say, 5 minutes or so.
Yeah, and it really since the customer is basically needs to create a new cluster, they could start with the multiple queues right away in their config. They don't have to start with the single queue config. I'm just for this demo, I'm showing that you can easily reconfigure your queue between single queue, single instance type, and multiple queues, multiple instance type, and I'm just showing the flexibility of the pcluster update command.
Yeah, right. Yeah. That's really neat. Thanks for showing it to us. We've got a blog post that's got a lot more detail on this. We'll put the link to the blog post in the show notes. We'll put some links to the ParallelCluster documentation that explains how to do this. We'll put that into the show notes. And then the last thing I really sort of want to promote is if you're watching at home. Oh, there's the almost infinite cloud turning up again. If you're watching at home and you've got ideas about future topics you'd like to see us cover in Tech Shorts, or you've got feedback for us, send a DM us on Twitter at TechHPC. If you like what you see, please hit the like button below. If you really like it, subscribe and share that with your friends and and your colleagues. And we'd really like to hear from you to guide us in the right direction to make sure that we keep producing some good shows and good content that's relevant to you. Angel, Rex, thank you for coming today, guys. Really appreciate it.
All right. Thanks for having us.
Yeah. Thanks for having us.
And I suspect we're going to be back here we'll be back here again in a few weeks' time talking about something else because you guys don't stop making new stuff. So we'll have to come back and recap one of the next things that you build. Thanks very much. Have a great one, guys.
Cheers.
Thank you.